So I'm closing the conference today by talking to you about legacy code. Some of you may have seen my session yesterday. If you didn't, this is me. I've been building systems since 1992. I used to be a webmaster many, many years ago. I live in London. I'm the CTO there at a company called Skills Matter. If any of you want to chat about any of this stuff, drop me an email. Come find me on Twitter. We'll talk about anything you want to talk about. Software, code, platforms, frameworks, whatever you like. Now, I spent a good chunk of my career working for these people. This is a company based in London. They're called Spotlight. Spotlight is like LinkedIn for professional actors. Does film, television, theater work, all kinds of things like that. And all of the projects that I showed you in that opening reel there, Star Wars, Doctor Who, Paddington, Game of Thrones, all of those were made with legacy code. And I know that because I wrote the code that they used to find the actors that they put in all those things. And I wrote it a long time ago. I wrote that code way back in the sort of mid-2000s. And lots of it is still running in production. And I don't work there anymore, but I still talk to the team who are now running that code base and managing that. So, one of the things that I'm going to be talking to you about today is what it's like running the same code base for 15 years and then handing that code over to a new team who are going to take over running it. So you'll get some first-hand experience. What is it like building the code in the first place? What's it like trying to get new people to understand it, work on it effectively, understand how it works? But also, I've recently changed jobs. I joined Skills Matter at the beginning of this year. I've inherited 75,000 lines of Ruby on Rails. I didn't build it. I didn't invent it, but now it's my responsibility to understand that code base and to work with the team who are managing it, understand how we can work effectively with that. So I'm going to be talking to you from kind of both sides of this. What is it like to create legacy code, and what is it like to inherit legacy code and to start working on it? But the other thing that I want to talk to you about is the rate of change in IT. Everything in our industry changes so quickly. And, humankind has never had an industry that changes as fast as IT is changing now. This is an antique. This is an iPhone 1. Anyone want to tell me what year this was released to the market? 2007. This thing cost about $800 when it was released in 2007. Now, if you went out in 2007 and you spent $800 on like a washing machine or a guitar or something, you'd still have it, and it would probably still work. Most of the time, if you spend $800 buying something in a store, you think you're going to get 10, 15 years of use out of it. This iPhone 1, it's obsolete. Even if you could find one that still worked. And you can't, because you can't replace the batteries in these. They're factory sealed. But let's say you could find one on eBay, you could get it up and running, you'd switch it on, you couldn't do anything with it. Because all of the applications, you can't install the latest version. You'd install like a version of the Twitter client from 2010, and you'd fire it up and it would go, endpoint not found. Because all of the APIs and all of the endpoints and the services that made the iPhone such a revolutionary device, they don't exist anymore. They have all changed. All of these things have been replaced and upgraded. And so this device now is basically obsolete. In 2007, I bought an iPhone. I also, at the same time, I went out and I bought a thing called a pod, which is it's an effects unit for electric guitars. And it had the sticker on the box. It said, online tone library, so you can make your own sounds, and you can upload them to the web, and you can download all these different settings and stuff. And it's really funny, because this thing still works. I still have it. I still use it. The online tone library is dead. It's just not there anymore. The website's been shut down. It came with a Java program that you could use to plug it in and edit it, and that doesn't run on any modern version of Windows or Mac OS or anything. It still works. The bit of it that's hardware, the guitar amplifier, is still fantastic, but all of the software features are gone. So it's like half of this thing is obsolete, and the other half will probably last another 10 years. And, I think that's really, really strange. This idea that the software half of something can go out of date while the rest of it is still in really good condition. And, part of the message here is the industry, the mobile phone industry, has locked us all into this idea that we get a new handset every 2 years. And so they can turn things over, they can change things. It's massive. There is so much money in mobile telecoms now that every 2 years they just like, well, yeah, we'll sell everyone a new phone and we'll push the new operating system. You know, if you've got a smartphone now, you wake up in the morning and, oh, they've upgraded my operating system. You remember when, if you were upgrading like from Windows 95 to Windows XP, you'd take like a whole weekend, and now your phone does it automatically while you're asleep, you know? It's this amazing proposition. And mobile phone companies, telecoms companies, they can get away with pushing this because they can afford to do it, because the cost of not doing it is massive to them. But a lot of companies have code in production that is as old as this, goes back to 2007, sometimes even older, and they don't get to refresh it and replace everything every 2 years. They have these systems that are still running, that are still in production, that are still making money, and one of the biggest challenges that we have as an industry, how do we deal with those kinds of code bases? So I have code running in production that I wrote when Concorde was still flying and when Friends was still on TV, 2001, 2002, and it's still there. It was written in classic ASP on Microsoft Windows, and that code is still running. That's the code that they used to make those movies and things we talked about. And, you know, people look at it and they're like, this is awful, this is legacy code. But, you know, how many of you here went to see, like, the Star Wars movie or Game of Thrones, and someone said, what did you think? And you were like, it was crap, you know. They made it with legacy code. You know, that's not how it works. The code solves a problem. And the people who use the code, they create these great things that all of us can watch and enjoy and appreciate. And maybe we need to think a little bit differently about what legacy code is and focus on, you know, what are the problems that it's trying to solve. So what is it, you know? We all agree, and everybody here, I think we can agree that legacy code exists. Yeah, it's a real thing. We all have to deal with it. Here's some code. Is this legacy code? What do you think? Raise your hand if you think this code is legacy code. 1, 2, 3, yeah, we got a couple of people. Is this because it says needs ugly hack for generic ref types in it? This isn't legacy code. This code, so let's imagine we invented this device. You plug it into your USB port, and you open up your line of code, and the needle here will move. How legacy is this? From 0 to 20, where 20 means this really, really legacy. It's stupid, right? It doesn't make any sense. That's not how the code works. You can't look at a piece of code. This is from benchmark.net. It's not legacy code because there's about 5 really smart people still actively working on this. And this is from a commit. It was in there for about a week, and then they came in and replaced it with something better. It's not legacy code because there are people who understand it who are still working on it every day. So we're going to need to try and come up with a definition. What is this legacy code stuff we talk about? Why is it a problem? Why do people talk about it so much? Because clearly it's nothing to do with the lines of code. You can't look at one line of code and say, is this legacy or not? You just don't know. You need to understand the situation. Now, if you go on Wikipedia, and you look up legacy code, and it'll say legacy code is source code that relates to a no longer supported or manufactured operating system or other computer technology. And then it says here, the term was first used by computer scientist George Olivetti. And there's a little number 1 here, so you're going to look up the reference, and it's a reference by a guy called Samuel Mullen. And you look at Samuel Mullen, and it says legacy code, and the only thing that cites is Wikipedia. Nobody knows who George Olivetti is, you know. This guy does not exist. I don't know where Wikipedia got this. I don't know where Samuel Mullen got it. So we don't know. And George Olivetti, maybe, is he here? Is George in there somewhere? I don't know where they got this stuff from. There are better definitions of legacy code we can work with. One that is very popular, that a lot of people are aware of, is this guy, Michael Feathers. He literally wrote the book, Working Effectively with Legacy Code. And his definition, legacy code is simply code without tests. Now, like Michael, I think he's a very smart guy who writes a lot of good stuff. I don't necessarily agree with his definition, because I think there is a better definition. Legacy code is code that is too scary to update and too profitable to delete. Yeah? Well, if it wasn't important, if it wasn't making money, we'd just throw it away. and get rid of it, because it wouldn't matter. And if we weren't afraid of updating it, we wouldn't be calling it legacy. We'd be like, oh yeah, it's good code. It's nice code. We like this code. And this is actually is very similar to a definition from J.B. Rainsberger, who has this definition, code is profitable code that we are afraid to change. So I want to talk about why are we afraid to change it? Why are we scared of editing the code that we are managing? Now, one of the oldest business practices that exists anywhere in the world is something called double-entry bookkeeping. It's the way businesses keep track of money income, money that they've spent, so income and outgoing. And what they do is everything they do gets recorded twice. When you pay a customer, you put in, okay, one, we've paid the customer this much money, that goes in your outgoing column. And then you say, okay, and we've taken this much money out of our bank account. That goes in your balance column. And the reason they do this is at the end of the day, you can look at these two numbers, you can add them up, and if they are the same, then you can be confident that what you have just done there is accurate. If they're different, it means somebody has made a mistake. Maybe you've forgotten to record something. Maybe somebody has been stealing money. Maybe one of your suppliers has been overcharging you or undercharging you. But the point is, because we have 2 points of reference, 2 different sources of truth, we can look at one and we're like, we don't know if this is correct. Let's go and check that against this other piece of information here and see if they agree. And that's an idea that I think is really important when it comes to thinking about software systems. So I don't know if you've ever seen this sort of famous cartoon. It's why you shouldn't interrupt a programmer. So that, sitting working on some code, so if C is a comma, then we'll backtrack 1. And then if the current character is a comma, set the backtracking flag. And then you start thinking, well, that's going to modify this, and that's going to modify this, and we've got this bit in the user interface that needs to know about it, and there's an entry point here and a configuration file. And then someone comes over and they go, hey, I just sent you an email about that thing. And you're like, it's gone. Where was I? You go back to the beginning, you start looking at it again. This thing. This is the mental model. This is when you build a system, when you create a greenfield system, what you are really doing. You are solving the problem in your head. You are thinking about and designing a solution, and then you are translating that solution into some code. And really, the solution is the thing that's up here. It's the thing you're thinking about. The code is just your best attempt, because the model in your head has no bugs. The model in your head is perfect, and then as you try and write the classes and the routines and the database tables and everything, that's where the bugs get in, because that's an imperfect process. And so often, if you're like a solo developer working on a greenfield system, that's your 2 points of truth. You have the model in your head, and you have the model that is in the code. And what you're doing, every time you find a bug or something, you think, these don't agree. The model in my head, the model in the code, these are different. Something has gone wrong. And you look at it, you're like, I see. And you update your mental model. We didn't support Unicode here. You update your mental model. We didn't anticipate how big this table was going to get. And so you're constantly balancing these two things against one another. Now, this is a fantastic idea from Jessica Kerr, Jessitron on Twitter, who did this great talk at Newcrafts in Paris this year. And one of the things that she mentioned in there is this idea, downhill invention, uphill analysis. Inventing things is easy, and it's fun. When we're writing code, it's like, whee, we're going downhill, it's great, we're typing code and everything. Reading code, analyzing code, trying to understand another system, that's like climbing up rocks. That's really, really difficult. This is why there are so many frameworks in the world, because someone is like, I need to solve this problem. I can build my own system, or I can learn React, or I can learn Angular, or I can learn Backbone or something. And it's much more fun building things than it is trying to understand things. Studying code is a really, really difficult process. Now, there's an essay, a guy called Alberto Brandolini, who has created event storming. He wrote this great article about something called the Dungeon Master. And the Dungeon Master is the person who wrote version 1 of the system. This was me at Spotlight. All that stuff I showed you, I wrote most of that by myself in classic ASP with nobody else, no code reviews, no unit tests, no staging environment. We didn't even have revision control for the first 2 years. We used to use beyond compare and just do FTP deployments. But I understood that code really, really well. And this is a problem, because it means that company got to a point where they're like, if Dylan decides to leave, we're going to have a problem because nobody else understands how this works. And we don't have anything. We don't have tests. We don't have a specification. We don't have documentation. All we've got is code and this mental model that's in my head. And this is the Dungeon Master anti-pattern. It's when there's a person in the organization and your 2 points of truth, one is the code, the other one is what is inside that person's head. And the big problem comes when you decide, what are you going to do when you start changing that code? When you start building version 2, how does the Dungeon Master fit into that model? What can you expect them to do? Some places, they say, well, we'll make them the product owner. That doesn't work very well, because the Dungeon Master, their mental model gives them a certain way of thinking about the problem, which can actually be a really bad thing, because it means they don't solve the problems that are real, they solve the problems they can see in their head. And sometimes those problems don't exist. Sometimes those problems don't exist anymore. Anyone in here use jQuery? Can anyone tell me why jQuery was invented? jQuery was invented because when it was first released, the browsers that were in use in production, Internet Explorer 8, Firefox, Chrome, Safari, they all exposed different APIs for doing dynamic HTML programming. And so you'd spent a lot of your time having to write special cases for different browsers. jQuery came along, and it's like, we're just going to put a level interface, the same interface on top of all these different browsers. That was the reason it was created in the first place. That isn't true anymore. Nowadays, you can write JavaScript and it'll run natively in almost every modern browser because they use the same interface. But there's still developers out there who their mental model of web development is still based on a day when browsers couldn't agree on how to implement basic things like get element by ID, this kind of stuff. So the mental model that the Dungeon Master has could be dangerous. You know, it's potentially out of date. Now, we all know the solution to this problem we have with legacy code is we want to stop it happening in the first place. We don't want the Dungeon Master. Yeah, it's fine. We don't want a system where the only source of truth is in someone else's head. So we say, all right, you know, we are good now. We're professional developers. We're going to build microservices in F#, and they're serverless. But if you look at the code that exists in the world, there's this much F# in microservices. There's this much which is ASP.NET with some tests. You know, it's testing something, we don't know what. This much of it is Visual Basic 6 on Windows XP. And probably 90% of the software that actually runs businesses in the world is Excel spreadsheets. Now, you know, Excel is actually a pretty good language. Excel is a pure functional language with no side effects. You know, think about that for a minute. But the software that exists in the world, and we need to keep this stuff going. We need to keep it running. Because it's out there, it's important. When you book a flight, you book a hotel, you book an appointment at the hospital, these are the kind of systems that are making that thing happen. It's not serverless F# with microservices, or it's not Haskell, or it's not, you know, .NET Core deployed to the cloud. It's applications like this. And we need a better way of dealing with this. Now, I think one of the other reasons why people talk about legacy code is fashion. We like to think that we're engineers and we're scientists and everything. But fashion plays a really, you know, things are cool and then they're not cool anymore. You know, there was a point when .NET was really, really cool, and everyone was like, I need to learn .NET. That's the new exciting thing. It's really well paid, and it's cutting edge, and it's amazing. And then, do you remember, like, about 5 years later, everyone's like, why I'm leaving .NET? And they all went, oh, we're going to go and do Ruby on Rails because blah, 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 blah. And then everyone's like, oh, no, we're going to do Python. And then everyone's like, no, we're going to do Bootstrap. No, Angular. No, React. No, this. No, that. No, Kotlin. Kotlin's new. And you know, I think there's a reason for this. And I think the reason for it is people are afraid that they are going to get left behind. You know, people, you talk to recruiters, you talk to hiring managers, and there's just this kind of thing that happens in IT all over the world. You take two candidates, you know, this is one of them. They got 3 months Angular, and they got 6 months working on Blazor, and 3 days doing WebAssembly, and 4 weeks Rust, and 2 weeks Kotlin. They got 10 minutes experience with Elm. And over here, we got this person, 15 years C#, 25 years of SQL Server and HTML. Now, this person, I'd put money on them to build a system that works well and hit their deadlines and everything. But if you go looking for recruiters and stuff, you know, this person is making loads of money because they got all the cutting-edge technology. And recruitment, I think, kind of drives this. And I think, a lot of the time, I've worked with some very, very good recruiters, but I've also worked with some recruiters who didn't understand technology at all. They're just kind of matching buzzwords in a database. And so when a young engineer talks to a recruiter, the recruiter says, you've got to learn Angular. You've got to learn Angular and React, otherwise you'll never get a job. And so then that person comes back to work, and they're doing C# and .NET 2.0, and they're thinking, I'm going to be unemployed. I'm going to die under a bridge. How will I feed my family? And so they go out and they learn Angular and they learn React. And I'm like, no. Think about the problem you're trying to solve, Now, one of the big things that I see time and time again with legacy code bases goes back to that definition, code that we are scared to change. Some words of wisdom.
Fear is the path to the dark side. Fear leads to anger. Fear is the path to the dark side. Fear leads to anger. Anger leads to hate. Hate leads to suffering.
Fear leads to anger. Anger leads to hate. Hate leads to suffering. Suffering leads to JavaScript. How do we stop people being afraid? How, as engineers, can we look at a code base, legacy code base? We don't want to fall into the trap of going, this is crap, we need to rewrite it. Because that doesn't work. All you do is you create different legacy. And then there are two legacy code bases. And the old one won't get shut down. And it won't get deleted, because that never happens. What you'll end up with is version 1 and version 2. And then the team who come in for version 3 will be like, we need to rebuild it all. And they'll start again, and you'll end up with version 3 and 4. And they'll all be running side by side. How do we create this confidence? And to me, confidence is about three things: understanding, trust, control. Now, trust is the hardest one of these things. There is an expression that trust is gained in drops, and it's lost in buckets. To build trust in something takes a long, long time. This laptop here, I've been using this on speaking trips and everything as my main machine for about 4 years. It's never crashed once. And I hope today is not the day. It's rock solid, absolutely reliable. First time this thing crashes in the middle of a presentation, that's it, I don't trust it anymore. I don't care if it's a one-off or anything, just that one incident, bang, it's gone. And working with code is the same. To familiarize yourself with a code base, or the trust that exists between the business and your team, you make little changes, like we've been up for a week, we've been up for 2 weeks, we've been up for 3 months, 6 months. The second you make a mistake, and that system goes offline, somebody will turn around and go, I told you shouldn't have changed it. And you're like, we have to change it. That's what you're paying us for, That trust is the hardest part of all of this. And it's trust in people. It's trust in frameworks. It's trust in operating systems. It's you being able to look at the components in a stack and go, all right, I know that the servers are pretty good. I know that Amazon Web Services is reliable. I know that Microsoft SQL Server is well trusted. This thing here, we don't know where we found this. It's like an open source framework that was on version 0.5 and it's unsupported and the GitHub repository is dead. That's the thing where we need to focus our efforts. We need to work out, can we trust this piece of our stack? Understanding. Now, when we study software development, you go to university and you do computer science or software engineering like I did. I wrote lots of little programs, tiny, tiny little programs like Hello World and like a little simple booking system for car hire and this kind of thing. I think the longest program I wrote in 3 years was probably 1,000 lines max, and that was like a big, big assignment. And it's like, imagine that you went to university to study Russian literature. You'd read Tolstoy, you'd read Dostoevsky, you'd read these big things. If you go to university to study medicine, they don't say, here's a human body, make a little hole in it. Cut off a toe, there you go. Here, cure this person, they got a cold. You study big things that exist. If you've got to study, let's imagine that you went to university to study architecture for buildings. And your first year, they're like, we're going to teach you to build wooden sheds, like a dacha or something. And second year, they're like, we teach you to build metal sheds. Third year, they're like, okay, advanced course, glass sheds. You never look at a building. You never go and study skyscrapers and warehouses and hospitals and factories. You just build these little sheds. And then you get out, you graduate, and you go and get a job, and the client comes to you and they say, we want to build the world's tallest skyscraper. And you go, I have a degree, I'm qualified, I can do this. And you start stacking sheds on top of one another. Because that's all that you've been taught how to build, you know? We teach people to write code. We don't teach people to read it. We don't teach people how to understand it. And there's lots of good code we can study. If you look on GitHub, you know, Microsoft.NET Core is open source. You can download it and you can study the whole thing. But there is a problem with that approach to learning code bases. War and Peace. It's roughly 30,000 lines, volumes 1 and 2 of Tolstoy's War and Peace. This is one of the, you know, the biggest works of literature that exists anywhere in the world, in Russian or in the English translations and everything. 30,000 lines. The Linux kernel is generally regarded as a very small, very efficient piece of software engineering. Anyone know how many lines of code are in the Linux kernel? It's about 140,000. Sake of comparison, Hamlet, William Shakespeare, Moby Dick, the Brothers Karamazov, The Lord of the Rings, Atlas Shrugged, War and Peace, that's the Linux kernel, that's the Mono framework, yeah? Looks pretty, doesn't it? I'm lying to you. This is a logarithmic scale. If you plot it on a linear scale, it's this. You know? This idea that we can study code the way we study literature, if you say to somebody, learn the Linux kernel to the point where they understand it and they can make changes with confidence and they know what's going to happen, that is the equivalent of asking someone to War and Peace, Atlas Shrugged, Lord of the Rings, and all the Harry Potter books. That's roughly the same size times number of lines as the Linux kernel. And the Linux kernel is small, you know. Our website at Skills Matter is the same size as the Linux kernel in terms of number of lines of code, and it's not a very complicated system. When you get into, you know, multinational, multi-language systems that do distributed transactions, you could be talking about millions of lines of code. It is not realistic to expect somebody to read the code and learn the system by doing that. There is just too much, and we don't yet have the tools that would allow us to do that. So how else can we study these systems? Anyone know who this is? Richard Feynman, Nobel Prize-winning physicist, really, really smart guy, really interesting person to read about his life, his work and stuff. And one of the things that Richard Feynman cared about a lot was education. And he spent, for a long part of his career, he would go to Brazil every year, and he'd work with the Brazilian government on how they could improve teaching science. And there's this great example in one of his books. He says, I go there, and I talk to these school kids in Brazil who are studying physics. And, I say to them, what is triboluminescence? And they say, triboluminescence is the phenomenon where crystals will emit radiation when they are crushed, when they are subjected to a force. And he's like, brilliant, I gave you a word, you gave me back some other words. And then he said to them, do you ever go to your house and you go into the closet in the bedroom, you close the door, and you take some sugar and a pair of pliers, and you crush the sugar and it flashes? And these kids are like, no. And he's like, that's what triboluminescence is. All you've done is you've taught these kids that if they see that word on the exam paper, they write this word. You haven't taught them anything about science. They don't understand what it is that they are doing. And, the point that he's making here is that for a lot of things in the world, we should try and learn them by doing experiments, not just by reading about them. What if we started treating our code bases as a scientific project? We're researching this mysterious entity that we don't understand its behavior. Now, there's a thing called the scientific method, which is kind of well understood, well documented. You start with observation. You look at a system. What does it do? How does it work? How is it behaving right now? And you formulate a hypothesis. I think if we do this, then this thing is going to change. And then you design a prediction. So let's take an example. You've got a bunch of products in a shopping cart on a website, and you notice that one of the products is never ever getting sold. Like nobody has ever bought this one product. And you look at it and you're like, that product name starts with a Z, which means it's always going to be at the end of the list. Maybe there's an off by one error in the way we're drawing our shopping cart. So you make a prediction. I think if we look in the code here, we'll find an off by one error and we'll fix it. And you do an experiment. You go and look at the code. You change something. You do some A/B testing. You change something and then you analyze it. You measure the difference. You look at your product sales. Did we find an off by one error? Yes. Did we start selling that product? No, okay, maybe the off by 1 error was not actually the problem here. You communicate, you tell people, what is it that you have just discovered? Has anyone else working on this? Anyone else got any ideas? You know, share it with your team on Slack, email, write a blog post, do something with it, report it at your retrospective that week. Because quite often when you get to analysis, you'll go, hang on a second. It's not an off by 1 error in the database. The problem here is we noticed on the front end, we've got a fixed height container. So the product list is always getting chopped off halfway down, which is why the things at the end aren't getting any sales. And you can go round and round this process, and you can improve your understanding of the system. Now, the problem with science and this scientific method is that when you first start out, you have no idea what you're doing. You don't know the system yet. That's why you're studying it. It's why you're trying to understand it. And so one of the most valuable things you can do is you need to find a safe way to do these kinds of experiments. So you've just inherited a code base. This is yours now. It's 100,000 lines, and you're in charge. If it goes down, you're going to get in trouble. So your instinct reaction is panic. I'm frightened. This is my problem, and I don't understand it. First thing to do, create a sandbox environment. Look at that code. Can you get it running on a laptop or a workstation? Now, one of the things I like to do with code is I check it out onto a laptop, I run it, and then I disconnect the Wi-Fi. And I see how does it react when it can't find the network. How many, because every one of those dependencies means that whatever you're doing here in your sort of local environment might be affecting the rest of the world. Maybe you're calling external API. Maybe you're sending, you ever accidentally sent real email from like a local development environment in a loop, and you get an angry customer like, why did you just email me 500 times? And you're like, I'm sorry, I didn't realize that was plugged in, We need to create an environment where we can do these kinds of things. So get the code, find out where the data lives. There will be backups somewhere, you hope, Get a copy of the backup, restore that locally. If you're using Redis, get Redis running locally. Use Docker, you can get container images for all these kinds of things. Spin them up locally in your workstation. Even get to the point, maybe you've got code that's so gnarly there's no config file. It is literally hard-coded to talk to api.payments.mycompany.com. So go and hack your hosts file and point that at localhost, and then run something like Fiddler and see which requests are coming in. And a lot of the time you'll be like, well, I can't run the entire payment system, but actually for the piece of code that I'm working on here, all I need to do is make sure that these 3 endpoints will return OK, and they'll give back some JSON. And you can fake that really easily. Run up a local web server, a local API server, just something in process. Any response just says, give back this JSON. Stick debuggers on it. Then you can watch the conversations between these different pieces of the system. By doing this, you can bring your code base under control. You can get it to a point where you can change something, you can see what it does, you can change it back again. You can measure the effects of these changes safely in a way that is not going to crash production, it's not going to impact any of the rest of the people on your team. You can start developing your understanding. And sooner or later, you're going to be like, I think I get it now. I think I understand. So the next step, next thing to try and do, take one change, something really small. Now, often the first time I do this, what I do is I just put a comment in one page on the front end, and I see what does it take to get that comment into production, so I can look on a production stack, right-click, view source, there's my comment. How do you go from your local sandbox where everything is safe to the production environment where everything is dangerous? Because the more steps there are in that process, the more danger there is that somebody will miss something and it will go wrong. So look at the whole deployment pipeline. Code, maybe you have a build process, maybe you have integration testing, maybe you have a staging environment, maybe you have a production environment. This is probably stuff that you inherited along with the code base that you were running. Now, this stuff's not easy. When Spotlight went from me basically writing stuff by myself and FTPing it to a point where we wanted to be able to do continuous deployment based on GitHub, it took 2 years to get to a point where we could reliably check in some code, build the code, deploy the code, test the code, and then push it out into production. But that became an automated process. It got to a point where something went into master, it would go into staging, we check the tests. If the tests are green, it's good to go on live. And we were retrofitting tests onto code that never had any before. We were using things like, Selenium, like a browser automation thing. We had ASP code, which you can't unit test because there's no runtime for it. So we're like, okay, well, let's deploy the code onto a web server, and then we'll actually test it by using Selenium to click this button and check that field and this kind of stuff. And yeah, it's hard. It took, like I said, a couple of years to get there. But we got to the point where it was automated, where we could deploy with confidence, where we had local environments where you could change the code, and you knew that whatever you changed, it was going to end up running on a live system without breaking along the way. Now, one of the really interesting things that we learned during this process is, it sounds weird, but the code that was built with technology that was not exciting was the easiest stuff to transplant. So we had a lot of stuff built in classic ASP, which is, I don't know, 15, 20 years old now. But you can go and you can get the latest version of Windows Server 2016 or 2018 or whatever the version is, and literally you're going to turn Windows features and ASP is here. You check that box, and all of this code just runs perfectly. You know, the code is 15, 20 years old, but it still works on Windows because Microsoft has always been really, really good at backwards compatibility for enterprise customers and things. We have some code that was built on ASP.NET MVC version 2. Do you have any idea how hard it is now? Because ASP.NET MVC version 2 never shipped with an operating system. It was a download, and it predated NuGet. So you had to download the DLLs from Microsoft's website and install it manually. And the DLLs are still there somewhere. But we don't. If you turn on ASP.NET MVC now, you get version 5 or .NET Core 1.0, whatever. You know, the version 2, you can't open the projects in Visual Studio anymore. The thing is, we didn't know this because these systems hadn't gone wrong. So nobody had to do any work on them for years in some cases. Anyone here drive a car? Do you know how the brake light on your car works? I mean, really, like, would you know if something went wrong with it, would you be able to just go in and fix it straight away? Because this guy does. Because this brake light fails all the time. And so the person who is responsible for this system, they have a very accurate, up-to-date mental model of how the brake light in their car works and what they need to do to fix it when it starts going wrong. This one, you know, not a clue, it's magic. And when the magic stops working, maybe you take it to the shop. Maybe you go on Google and find a YouTube video that shows you how to replace a bulb. You know, but you don't have this immediate model. The systems that people understand the best are the ones that keep failing, because those are the ones that you keep having to go back and work on. The systems that work well, you know, just ticking away in production for 5 years, 10 years, suddenly one day somebody says, everything's failed. None of our stuff is working. And you know, we had a real example of this, the best one I've ever seen in my career. Somebody went to publish a job on Spotlight, and it failed. And it failed because it couldn't create the personalized emails that were going out to all of the members. And you know, we're sort of looking at it going, this has been rock solid for like 2 years. What's happened? And someone went, the ID number of the personalized email is 2,147,000, and I thought, oh, crap. We've just overflowed 2 to the 32. We've sent so many emails that one of our database tables can't cope anymore because it's only a 32-bit integer. And we've sent so many of these notices out that it won't fit. And actually, in this case, the database table was a 64-bit integer because we'd thought of that. But one of the systems that was integrating with it didn't know about this. And it was just using link to SQL, and it was using int. And so we had this, you know, good idea. If you ever do use a 64-bit integer, don't seed it at 0. Seed it at 2 to the 32 plus 1. Because that way it will blow up on the first day it goes live. It won't sit there quietly for 5 years and then blow up one morning when you're in the middle of doing something else. So there are these little patterns you can do to kind of, you know, just make sure if something might go wrong in future, see if you can make it go wrong now. Because then you can fix it now, like this guy with the brake light, while your mental model of it is still clear in your head. And the best way to promote this kind of understanding is to transparency. Take the important pieces of your system and do what they do in Star Trek. Put them right up there where everyone can see them. Build monitoring dashboards. You know, you got a system that's been running in production for 5 years and no one's looked at it. Just take a moment, put an endpoint probe or aggregate the log files somewhere, just so you have an easy way of seeing what's it doing today. We're not talking necessarily about getting a full development environment up and running. We're talking about minimal visibility. We're talking about noticing that something is a little bit slower than it was last month, and a little bit slower than it was the month before that, because then you can sort of plot this graph. I think when we get to here, we may have a problem. And then you can start looking into things before they blow up. This transparency is a really, really important practice. Now, one of the big sort of problems I think we have in IT is we sold people solutions. You ever hear this? We're an integrated solutions provider. We deliver solutions. We deliver business solutions. And a lot of the time, certainly in the earlier part, the 1980s and 1990s, where a lot of these legacy code systems were first put in place, someone would go into a company and they'd say, we can automate all of your stuff, and then you can fire all of your staff, and the computer will do everything for you, and it'll be much more efficient. And I think as an industry, we didn't explain you're going to need engineers maintaining your code for the rest of your life. We solved the problem that existed on one day in the year 2002. And, even when you're doing this really, really well, you talk to all the people, you talk to the stakeholders, you talk to the business analysts and the staff and the reception staff and the customer service staff. But what you get is a snapshot of how the company operates that one day or that 1 month when you're doing your requirements analysis. And that, in companies where people are trusted to do jobs, that process is changing all the time. And so what you do is you bake this one thing into it. You build like a check-in system for a hotel, and you roll this thing out, and then someone comes in and goes, oh, could you tell the kitchen that I'm allergic to onions? And when it was manual, they'd just make a note on a receipt. They'd be like, allergic to onions, and they'd send it to the kitchen. And now suddenly they got this computer, and there's no button for it. So they come back to you, they're like, we need a change request. And you say, oh, it's going to cost you money. And they go, okay, maybe we can do without it. And so you get these systems that no one's looked at in years because there is a cost of changing them. And I think that's a conversation that, the IT industry and our customers, our clients, we just be more open. Like, this isn't magic. We're going to build you a system that works today. We'll do it as cheap as we can, but you're going to need to keep changing it. There is an ongoing cost. It's like you build a new office building, you're going to have people come in to repaint it. You're going to have people to fix the electrics. You're going to have people come in and clean the place and all this kind of stuff, these maintenance tasks. Because if you don't take these kind of things seriously, you get legacy code incidents. You're in the middle of building the new shiny feature, and suddenly, boom, we can't send email. Boom, the database has fallen over. Boom, we tried to restore one of the backups, and it's corrupted. Without seriously understanding the cost of owning these systems, there are these risks, these ticking time bombs that exist, and we need to understand them better. Run code in sandboxes, do audits, look at every single component of the system you've inherited, start at a high level, get an understanding of what they all do, see if you can run them locally. Look in your databases. Are there any IDs that look suspiciously like they might be about to overflow soon? And again, this is hard work. It takes time, but it's really, really important and valuable to do it. Get the confidence to alter the things in that system and measure them so you can understand the effect that your changes had. And finally, this is what a successful software project looks like. Code is deleted. GitHub's archived, the databases are offline, you've decommissioned the servers, and the team is at the beach drinking beer. Yeah? This is a successful software project. This is one that is not going to go wrong ever again. And we don't think about this as part of the life cycle. When we build software, nobody ever says, when are you going to delete it? You're like, of course we're not going to delete it. It's magic. Look, we built you this amazing distributed platform for doing real-time Bitcoin blockchain concurrency transactions. But if we went to them and said, you know what, this thing here, this will give you 2 years. Like, this will give you your jump. This will get you into the market. This will get you your first wave of customers. But you need a business plan. In 2 years' time, we're going to delete this and we're going to go to the beach. And your business needs a plan for what you're going to do, and we do that. Because the way we're engineering this code, this is version 1. This is the MVP. This is a prototype. It has a lifespan, We're going to validate the concept. I was talking with someone recently about Rails, and they went, oh, yeah, well, Rails didn't really work for Twitter. And I was like, okay, 1, you are not Twitter. Your company is not going to get 3.5 billion users. That's just not going to happen. 2, if you think Twitter is an example of a failure that you are trying to avoid, Twitter is one of the most successful software startups ever. And yeah, they used Rails and MySQL to get something into market. Anyone remember the fail whale? You used to get in the earliest days of Twitter, when it first hit its really first big growth curve, it used to go down all the time. And when it did, you got this picture of a whale with this little bluebird trying to lift the whale up, and it got known as the fail whale. And then they upgraded their platform, and people actually missed it. They're like, I haven't seen the fail whale in weeks. I hope he's okay. It's like, Rails worked absolutely fine for Twitter to validate this idea that everyone wants a microblogging platform. And then when everyone joined that platform, they're like, right, now we need to do some serious engineering to get this thing up to speed. So they kind of understood that the code they were using for that version 1, it's not going to be around forever. It's not going to be around for very long at all. And that is, I think, the third fundamentally important part of managing code bases. You need to get to a point where you have a plan to get rid of it. You need a plan to shut this thing down, you know. Now, the world we live in today runs on code, and most of it's legacy code, because it's the code that does important things. It's the code that we use when we travel, code we use to book into hotels, hospitals, you know, even social networking, what we think of as successful startups. They've got code in there that the people who wrote it have left, and it doesn't have any unit tests. I bet you they do. And we just need a better way of reasoning about this. We need to appreciate the value that this code creates. We need to get past this mindset of, we look at the code, first thing is we're frightened, because it's big and it's complicated and it's our problem, and we don't want to be the one who crashes the production system, you know. And then we get upset. Fear leads to anger. We're like, who wrote this? This is a piece of crap. Oh, it was me 5 years ago. Yeah, I remember, you know. And then you get to the point where you're like, I hate this. I want to quit. I want to go somewhere else. But every place you go to now, almost every place, there will be some legacy code that we as an industry, we as engineers, need a better approach for dealing with it. And the solution has been staring us in the face the whole time, ever since MS-DOS. Control it, alter it, delete it. It's how you learn to love legacy code. Thank you. I believe we have time for some questions. Yes. Do we want to use a mic for questions, or are we just... just shout. Hey, code is awesome. You know, thank you. I love what I do. I love working in development, and I love coming to things like this where you get to talk to people, because it's easy kind of, you know, day to day, you go to work and there's something gone wrong with your project. It's easy to get kind of demoralized, because a lot of the little stuff is hard. But you take a step back and you're like, this is pretty amazing what we all do. So thank you. And yeah, I'm glad you enjoyed it. Any other questions? Cool, all right. Well, thank you very much, .NET Fest. Duže děkuji. I maybe see you next year. Maybe see you somewhere else. It's been a really good conference. Thank you all for coming. Do pobачення.